Hello, good morning everyone. I welcome you all in the third lecture of Software Engineering and Project Management. In the second lecture, we discussed about various software myths, right? What are the various myths? What are the misconceptions regarding building a software? So, I hope you have a clear idea now what are the myths, what is software engineering basically, and why we need software engineering basically. Right. Now again just revise the importance of the software. Okay. In this slide you can see the importance of the software engineering. We are having various importance. Just for example you can see first is it will help us to reduce the complexity of our overall software. Right, because we are going to follow a systematic approach. So that approach, or you can say an engineering approach, that will help you to reduce the complexity of your software. It will also help us to minimize the cost of our software. And if we are following an approach in a systematic way, so we can also handle the large project easily. We have also discussed the example of that hut building and then that 15 stored building. So what you can say, you can handle a large project. We can handle a large project easily, and also we can make a effective software. We can make a reliable, whatever the software you are making, that will be reliable, and also it will not take too much time, because when we are not following any approach, we are not aware about any approach, what we do basically, we just follow a trial and error concept. We make a small part and then again we check it. So it's a wastage of time. It wastes a lot of time. So by using a systematic approach, by using an engineering approach, we can make a good and effective or quality software. Got it? So this slides indicates the importance. This is just a summary. We have already discussed a lot of things, why software engineering and all. This is just a summary that it will help us how this software engineering subject will help us, or it gives us the important concept, right? Important concept to build a software. You can make a good software. Okay, now discuss the goals for software engineering. See, if we are learning the software engineering, so what is our ultimate goal? Right? What is our ultimate goal for the software engineering? What we want to do basically, we want to build a system. We want to build a system, very good system, a quality system. So if you want to make a system, and suppose by following an approach you are able to make a good system. Now after making the system, which question comes in your mind? How will we know the system works? Right? Definitely there will be some procedure which help you to identify whether your system is working properly or not. Only not the building up system is a question, its correct working is also a question. So how do we know the system works? See, we can identify, we can give some input, and then by checking its output we can identify your system is working properly. But what type of error comes when the system's not working properly? Right? What type of questions arises? See, so learn a term first, that is a buggy software. Buggy software is really a very huge problem. If you are working a very big software, if it's a small software it's okay. The bug means a simple error that you can easily identify. But if you are working in a very large system, buggy software is really a big problem. Just see, a software bug, it's a simple error, right? It's a flaw or a fault in a computer program or a system that cause it to produce an incorrect or unexpected results, right? Or to behave in unintended way. It produces a result which we are not expecting. What we are saying, how we will check, how we come to know the system works? We will give some input, and then after giving some input we will get some output. Okay, but when we are not getting the correct output, when we are getting the faulty results, when we are getting the erroneous results, that time we can say there is a bug and the error, right? There is a bug and the error. it is not giving us the expected result. Got it? So this is the one issue with the very large systems. Next, the second point is the defects in softwares are also commonplace. We are saying that there is a bug, so definitely that bug may come. Na? Why bug will not come? We are also human being. When we are developing a system, lot of errors may come. So defects in software is a very commonplace, and even in software it is a very common. In software, we are making a software, like it is a very common than other engineering disciplines. Other engineering disciplines, it means suppose when you are building on a large thermal power plant, you are working on some project there. If you are working on building a say large bridge, okay, so in place of those disciplines, if you are talking about the software, defects are very common here. Got it? So when you build any software, which is your goal, you have to check whether your system is working properly or not. And why your system not work properly? Because of the bug. Okay, we will discuss everything in detail also. Now just try to understand, when your system is not working, definitely there may be a bug which we are not able to find out easily. That's why it's not giving a correct result. Now check some examples of the software bugs. See, the space disaster. I think most of you have learned about this term, that the maiden flight of the Ariane 5 rocket on the 4th of June 1996. What happened there? The reason was the reason for the explosion was a software error. You can see whatever is happening, you can see from the picture. The reason behind this is a software error. What? It's attempt to cram a 64 floating point number to a 16-bit integer field. Right? There is a floating point error, floating point number errors are there. And again, because of this you can understand from this picture what is happening here. Right? So why these disasters happen? These disasters happen because of the software error. Because of software error, and we are having the financial loss of this. You can read the digits. Right? Even it's in dollar, and it includes the indirect cost also. So you can see, if there is a software bug, you can see the financial loss. Got it? That's why we are saying it is a like more dangerous than the other fields. Similarly, you can see the other example, say air transport example. You can see from the figure, like the Boeing, it could not assemble and integrate the fly-by-wire system until it solved problem with the data bus. Okay, and the flight management software. There was an issue with this flight, and the issue, when they try to solve that issue, it take more than a year. Right? And then in April 1995, the FAA certified the 777 as a safe. So total development cost was $3 billion. Okay, $3 billion was the total cost, and then the software integration and the validation cost was 1/3 of this total cost. So these are some example. This is related with the air transport. You can see more examples of the software errors. See, in this you can see, if this is related with the medical field, right? This is related with the medical field. Suppose, okay, in this what we are doing, in this they are doing some radiation therapy or radiation control. They are passing the rays here. Got it? Suppose if they have passed the wrong one, in this what they have done, in place of passing the correct thing, they have passed some wrong one. Right? This the targeted volume, in place of just covering this part, they have covered this big part. So it created a lot of issues. This is also software error. Most of the people died from this error. So what happened? This is also a software error. Again, software error is, you can see, this is also a software error. If you remember, I think in 2010, in 2010, 30 billion debit and credit cards have been rendered and unreadable by the software bug. Also, we have discussed this is a radiation therapy example, right? Like one or two people, I think they died, and the six people were overdosed because they all are based on the software. Also, you can see this last one, this car one. This is a software in modern car, and it is having LOC, means the line of code. It is having 100,000 line of code. And then in 2006, error in petrol pump software. This is the modern car, and there was some error in the petrol pump. Got it? There was an error in the petrol pump, and because of that error, they have to call this 1,28,000 vehicles again. Got it? So how many examples we have seen? We have seen, say, this overdosed example. The next is the credit card example. The another is the car example. Also the previously the aircraft example, right? That the rocket example, space disaster. So whenever you are making a system, right? Whenever we are making a system, we have to revise that system multiple times. The reviewing that system is very important. That's why we learn the software engineering approaches. How we can make a very effective software or quality software, error-free software. See, when you are making these, like when you are working on any of the software, suppose you are working on this software, petrol pump software. So where the error may come? Error may come at the design time, or it may also come at the coding time, or it may also come when we are getting the requirements from the user. So there are various phases, there are various steps involved. So error may come at any place. That's why you have to review each and every step multiple times. Got it? So now, like till this slide, this is all about the bugs of software, like bugs of the software. Got it? Now, the financial impact of the software error, right? As we have discussed, we are having the lot of errors, so the lot of software bugs are present. But what is its financial impact? As per the Cambridge University report, they have showed that we are having around the $312 billion annually. Like the cost is around, we have, that is waste, that is we used or we waste on that to repair the software bug is around 312 billion. So you can imagine that it's really a wastage of amount. It's really required a lot of time, lot of amount is wasted. Got it? When we are using or building a software, try to remove the errors, try to work on each and every step very properly. Got it? So what is our goal? What is our goal? Our goal is to make a reliable software, okay? Or to increase the software reliability. As we discussed, one of the importance of our software engineering is the software reliability. Got it? So till now we have discussed about the various software errors, right? Basically, what is our goal? Our goal is to build a software, right? We want to build a system, but how you will check whether your system is working or not? If you are not getting any error, it means it is okay. But not only getting the error is a one, like it's the only one way. There are multiple ways, but if we are getting errors, there are various bugs, and then because of those bugs, we have also discussed about the financial loss. We have also discussed about the various examples, right? So our goal is to increase the software reliability. Now from this point, from the next slide, we will discuss about the technical term in the software engineering. See that? Now we will discuss a very generic view of the software engineering. The software engineering is a layered technology, right? It is a layered technology. From this figure, you can see we are having 4 layers here. We are having 4 layers. The very basic layer is a quality layer. It is the quality layer, right? So our engineering approach, our software engineering approach is a layered technology, right? Or there's one more point that you must remember, that any engineering approach, right? Any engineering approach must rest on an organizational commitment to quality, right? And this quality culture, right, this quality culture, it ultimately leads to the development of increasingly more effective approach to software engineering. When you are building a software and if you are maintaining this quality, definitely ultimately this will help you to increase the or use the approach effectively, right? Or you can also say it is a bedrock that supports software engineering, right? It is a bedrock. Quality is also a bedrock which is supporting the software engineering, and the support of the software engineering is a quality focus. But which is our next layer? The next layer is the process model. Got it? Process model. The software engineering process, it works like a glue that holds the technology layer together, and it also enables the timely development of computer software, right? So the process, you can say the process of this second layer process, it forms the basis for management control of software project, and it also establishes the context in which technical methods are applied. Got it? It also help what are the way in which the technical methods, the methods is the third layer, technical methods are applied. Got it? And how work products are produced. It also helps us to identify the milestone, right? How the quality will be assured, and change in the process or change in the approach, take whether we are managing the changes properly or not. So this is the second layer of the software engineering model, that is the process layer. The third layer is the method. Third layer is this method. Got it? This method, it provides the how, the answer for how, for building the software, right? Basically it encompass a broad array of tasks that includes, it again involve number of tasks that include communication, requirement analysis, design, programming, construction, testing, support and all, right? The software engineering method, this method, it rely on a set of basic principles. Got it? It also rely on a set of basic principles, right? And then the last is the tool. This tool provide the support. That support may be automated or semi-automated for the process as well as for the methods. Got it? These tools are integrated in such a way that information created by one tool, it can be used by the other tool also. The example for the tool is like a case tool, that is computer aided software engineering. The example for this tool is CASE, computer aided software engineering. So this software engineering follows a layered technology. Got it? Sometime in exams this question comes that explain the layered technology. The first layer is your quality focus, then is the process, then your methods, and then the tool that you can use it. Example is the case tool. Got it? Now we focus on, from the next slide we will focus on process. Got it? Now just what is the motivation behind this process? Just take this scenario. You want to make this plant, right? You want to make this plant, and then you are having lot of things, like you are not clear that how to use all those points, how to collect them, how to arrange in a way, how to do it, how to move ahead, right? So this process, it helps us, it provides a systematic way, it provides a systematic approach. Got it? Which helps us to build this project successfully. So basically the process motivates us to finish our task effectively and on time. Got it? Again, see, suppose when we are making a process, got it? When you are working on a process, you are following a process to make a project successful. So you will come in contact with various persons. Suppose you are working on a software project and you are a software developer. So not only you will work there, some technical persons will be there, manager will be there, and also the user will be there. Got it? A user will also there. So when you are working on a project, you work on a team, you communicate with the multiple people, right? All the peoples will involve in our project. They will involve in our project and they will also help us for the completion of the project. So this is the essential, right? These are the essential for the process. Now check the process, all the WH questions about the process. See, now what is the process? Basically it is a series of predictable steps that leads to a timely high quality product, right? Or you can say it provides us a roadmap. It also provides us a roadmap. See, basically when you work for building a product or a system, right, it's important to go through a series of predictable steps. It's important to go through a series of predictable steps. It provides us a roadmap that helps us to create a timely and a high quality result. Just for example, suppose you want to go to the Dharampet, right, from our college. So there are multiple paths which you can follow to reach there. But if you will follow a path where there is very less traffic, right, very less traffic is there, and that road is also safe, you can go from there, so you can reach to your destination easily and on time. So when you are able to reach to your destination properly and to reach to your destination on time, you follow a particular process, you follow a particular path, right? The process provides a proper roadmap. Similarly, if you're working on a very big project, this process will provide you a path. And who will involve in this? Manager, software engineer, customers, software developer, technical persons, users, they all will involve in this, right? And then why process is important? See, because this process, it provides a stability, controlled, and right, and it also provides an organization to an chaotic activities. It also provides organization to chaotic activities. As you can see in the previous slide, like in the motivation of the process, multiple tasks are given to complete your project. The plant suppose that was a thermal power plant, complete the thermal power plant project. But if you don't know how to organize it, how you will use it? Got it? So that's why it is important. Then what are these steps, right? What are these steps? So it's a handful of activities, and these are common to all software process. Basic steps that we will discuss, we will follow the basic steps, and all these steps are common to all the software processes. But the details, like inside that step, what we are doing, that differs basically. Got it? And just for example, one process might be appropriate for creating a software for an aircraft avionics system, right? Just for example, one process is good for creating a software for aircraft avionics example, while an entirely different process would be indicated for the creation of website, right? It means steps, there maybe you can follow the same steps. Same step means you will get the requirements, you will analyze it, you will design it, you will code it, and then you will test it. But the way you will perform it, if you are working for an avionic craft system, definitely code you will write in a different way. If you are developing a website, you will use some other details, right? So basic steps are same. What are the work products? What are the work products of this process? What is the work product? So the work products are, these are the programs, document, and the data that are produced as a consequence of the activities as a consequence of activities we performed and the task defined by the process. Okay, and the next is the correct, right? Correct process. How you will say it's a correct process? You will assess it, and then like by doing some assessment, and then by the quality. Got it? It means correctness means how do we ensure that we have done it right? We have done it right. Okay. So this is the process basically, and these are the basic questions related with the process. What is process? Now you know what is process. Got it? Who will involve in this process? Why process is important? What are the steps involved in the process? What are the work product? It means what are the output which that will produce as a consequence of activity, whether your process is correct or not. Right. Now okay, again just check why process. Okay, why process? A process defines who is doing what, when, and how to reach a certain goal. Now from the previous slide, I think this is clear. A process defines who is doing what, when, and how to reach a certain goal. To build complete software process, what you have to do? To build a complete software process. Now we are saying we are going to build a software, but just think, when you are going to build a complete software process, definitely it will be very big. So what we try to do? We identified a small number of framework activities. Just note this point. Framework activities that are applicable to all software projects regardless of their size and complexity. There are some framework activities that will be followed inside a process, and it does not affect the size or the complexity. We will follow the same activities. Got it? And this process, it also encompasses a lot of umbrella activities that are applicable across the entire software process. It means like in that whole software process, we will identify some process, again some small process inside it. We will call them the framework activities, and then again we will perform some umbrella activities. Ultimately we are going to perform multiple activities. To complete a task, you have to perform the multiple activities. You call it a framework activity and an umbrella activity. Now see this. Got it? Check this. This is a common process framework, right? It is a common process framework. This framework established the foundation for a complete software process by identifying a small number of framework activities, right? And all the framework activities are applicable to all software projects regardless of their size and complexity. You can see it's a common process framework. Got it? It's a common process framework, right? These are the framework activities. We will discuss everything. These are the framework activity. Again, inside this we are having some umbrella activity. Got it? We are having some umbrella activity. Now to build a high quality software, you have to follow the software process framework, right? We have to follow the software process framework, right? You can see this framework activity, right? This framework activity is populated by a set of software engineering actions, right? It means a collection of the tasks. You can see it is a collection of tasks that produce a major software engineering work product, right? Each action is populated with individual work that accomplish some part of the work implied by the action. So inside this framework activity, we perform multiple tasks. We will set some milestones. This indicates the software quality analysis point as SQA. Then we will have some deliverables. We will perform some task. To perform that task, definitely we will set some milestone, and then after task is performed, we will have some deliverables, we will have some output. So we will perform the various tasks, right? Again, see, this is the whole software process framework, right? See it one by one. We have a software process. You can see this is software process, right? this software process is defined by a process framework. Got it? Inside the process framework, we are having the various umbrella activities. And again inside the various umbrella activities, we are having various framework activity. As you can see. Again, what you can do inside a framework activity? You can write various actions inside it. Right? Again, as we discussed in the previous slide, what is framework activity? Framework activity involves the various tasks. See here, if you want to perform some action, right? You are performing say action 1.1. So definitely there will be some task set, the work task, some product, some quality analysis points and all. Right? Again, you are having second action, right? Inside the second action, again we will perform some task. Now we are having the second activity, second framework activity. Again inside it, we are having some actions. Then we are having next action. So this is the overall process framework. You can see the hierarchy here. This is your process. Got it? What is process? This is your process framework. This is the process framework. Inside a process framework, you are having multiple umbrella activities, and then umbrella activities involves the multiple framework activities, right? It is a set of multiple framework activities, and again inside each and every framework activity, you are having multiple actions, right? Sometimes in exam, this question comes like what is software process framework? So this is the software process framework. What is the importance of process? What is the software process framework? Got it? So you can see this hierarchical diagram. Now, what are the generic process framework activities? As I told you earlier, there we follow a common approach, right? We follow a common approach, a common steps. Even the details inside the steps vary, but these are the very common steps that is followed by any process. It is a generic process framework, 5 activities. Right? These are the 5 activities of generic process framework. Got it? The first is the communication. First is communication. Right? See, this framework activity, it involves heavy communication and collaboration with whom? Customer and other stakeholders, right? And it encompasses requirement gathering and other related activities. Basically, this communication task will help us in requirement gathering. Got it? Second is the planning activity, right? Planning activity, it will help us to make a plan for the software engineering work. It will help us to make a plan for the software engineering work, right? It also describes the technical tasks to be conducted, the risks that are likely, the resources that we required, the work product to be produced, and the work schedule. So during the planning, we will think about all the things. We will think about the related like risk. We will also think about the resources required, the schedule, what will be the output and all. The third is, in generic process framework, third is the modeling. This activity, it encompasses the creation of the models that allow developer and the customer to better understand the software requirement. Got it? And the design that will achieve those requirements. Model means you will prepare a simple model. Got it? You will prepare a simple model. So this will come under the modeling part. Construction. What construction will do? Basically, it will combine the code generation. Right? It will combine code generation and the testing. It means like you can again divide it in 2 parts. We will see, like you will see in next lectures, that construction is a combination of coding and the testing. So that's why we are saying it's combined the 2 activities, code generation and the testing, and which helps us to the testing helps us to uncover the errors, and also coding will help us to run the program. So the construction means we are doing the coding, right? If we are making the projects a thermal power plant, the construction means making up that plant. And again, sorry, this is not the construction, this is the deployment. right? This is the deployment. Please note it down. This is the deployment. This is not construction. Just wait. Okay, this is the construction. No, this is the deployment. So in the deployment, what you will do, it means deliver the software to the customer, deliver the software to the customer who evaluates the delivered product and provides a feedback based on the evaluation. Okay, and it provides the feedback based on the evaluation. So these are the basic 5 generic process framework activities that you should remember when you develop any software. You can also call it like the CPM/CD. It's deployment. We also call it like the CPM/CD is the communication, planning, modeling, construction, and the deployment. Again, inside the construction, we are having the 2 part, coding and the testing. And again, when you will learn in detail in the next lectures, you will see this this modeling means analysis, model and design model. Okay, so these 5 generic activities, it can be used during the development of the programs. It can also be used in the small programs as well as in the large program. It can be used to develop a large web application. It can be used to develop a complex computer system based program, right? But the details of the software process will be quite different in each case, as we discussed about that the aircraft system and then the web application or the website, but the framework activities remain the same, right? This is the main point you should remember. The framework activities will remain the same, but you can change the details, right? The details will vary, but the framework activities will remain the same. Okay, fine. So the next is umbrella activities. Now we will discuss about the umbrella activities, right? What comes under the umbrella activities? See, software project tracking and control. Got it? Inside the umbrella activity, your first if you remember, like inside the first inside the umbrella activity, the first task is software project tracking and control, right? What it does basically, it allows the software team to assess the progress against the project plan, right? You will check the progress against the project plan and you will take the necessary action to maintain schedule. Got it? Because you are tracking it, so you will track the plan and then you will take the necessary actions. You will take the necessary actions. Got it? Here you will also take the necessary actions behind it to maintain the schedule. If you want to maintain the schedule, you will take the necessary action. Got it? Next is the risk management. Okay, it will help us to assess the risk that may affect the outcome of the project or the quality of the project. It means during the umbrella activity, we will also perform the risk assessment. We will also perform the SQA. This is SQA, right? This is SQA. Like you call it a software quality analysis. This is SQA. Got it? This is the SQA. So, what is SQA? It defines and conducts the activities required to ensure the software quality. What is the fourth one? That is a formal technical review. Formal technical review means reviewing your project, reviewing your work multiple times to uncover the errors. Just for example, when you work, when a project is allotted to you, you perform some task and then you again come to us and said, madam, we have performed this task, please check it. We evaluate it, we give some, we provide some review to you and then you again go back. This is the formal technical review. We also call it like a FTR. Got it? FTR. So this also comes under the umbrella. Next is the measurement. Got it? What this measurement will do? It will help to define and collect the process, project and product measures that assess the team in developing the software. Right? That will assess the team in developing the software and which meets the customer needs. Okay. Then next is the software configuration management. Software configuration management, it will manage the effect of change throughout the software process. It means, suppose you have developed a software, right? After developing the software, when you have delivered it to the customer will read it, and customer will see whether it's working or not, and then again he will tell you some changes. Or might be possible that your software is taking too much time for completion. It's taking 1 year for the completion. So might be possible after 6 months the requirement of the user change. So user will tell you there is a change in this requirement. So the software configuration management will manage the effect of this change. Got it? Next is the reusability. What reusability will do? Basically, it defines the criteria for product reuse, right? What it includes? It includes the software components, and it also establishes a mechanism to achieve the reusable component. So this is the reusability feature. Again, the last is the document preparation and production. In this, and what it requires, it is required to create work products such as, what are the work product? Document, model, logs, forms, and list, etc. Right? These umbrella activities we applied throughout the software process. Remember, throughout the software process we applied this. Okay? So, in this, we have seen the software process framework. After software process framework, you can see there are various umbrella activities, right? Inside the umbrella activities, there are various framework activities. We have discussed about the generic software process framework activities. We are having 5 generic process framework activities: communication, planning, modeling, construction, and then last is deployment. And also we discussed about the various umbrella activities, right? So there is a difference between the umbrella activities and generic process activities, because the measurement, risk, reusability, configuration management and all this comes under the umbrella activity. We will deal with each and every point in detail. What is SCM? What is SQA? Right? That we will. So I hope this lecture helps you to understand what is process basically and what is the importance of the process in our software engineering. What is the importance of process in our software engineering? This will hope this lecture provide you a clearer view, right? If you have any doubts, you can ask me. You can ask me by mail, and even if you want, what you can do, both the shifts can discuss and you can decide a time, and then I can answer your query. We can schedule a lecture as per your time, a common time, and then I can solve your queries online also. And if you have any issue regarding the subject, if you are not able to understand, you are getting some type of not able to understand, you are getting some issues, you are not feeling that the voice quality is clear or not, so please provide me a feedback, so at least I can work on those points again. Got it? This is theoretical subject, not too much theoretical. I will try to make it practical as much as possible as we are taking the example. So I think from the next to next class we will start with the model. So there is no theory from the next to next class. We will see all the models and all various models are available, right? So just try to understand it in a practical way. Whenever you are listening to lecture, so just listen the lecture, pause it. After pausing it, just think it, yes, the process means this way we will do the process. These are the tasks available to us, but how we will complete, how we will combine all those tasks, we have to perform a particular process. This way you have to think. Then only you can get a better idea of the subject. Okay.